are used to find an equivalent value. So for our first identity rule, we have sine of theta squared plus cos of theta squared is equal to 1. For our second rule, we have sine of 90 degrees minus theta is equal to cos theta. And for our third rule, we have sine of pi over 2 minus theta equals cos theta. So these two rules, 2 and 3, are the same because 90 degrees is equivalent to pi over 2 in radians. So those two rules are the same. For our fourth rule, we have cos of 90 degrees minus theta is equal to sine theta. And for our fifth rule, we have cos of pi over 2 minus theta is equal to sine of theta. The same thing goes for our 2 and 3 rules as it does for our 4 and 5 rules. 90 degrees is equivalent to pi over 2 in radians, so our rules 4 and 5 are the same. For our sixth rule, we have tan of theta is equal to sine of theta over cos theta. And that's our identities.
Okay, so an example of how we use identities is through this question. So if sine of theta equals 4 over 5, find cos of theta if theta is between 0 and 90 degrees. So straight away we know that theta is going to be in the first quadrant because that's between 0 and 90 degrees. Okay, so straight away we know that we're going to use our first identity rule, and that is because we've got sine and cos. So we know sine of theta squared plus cos of theta squared equals 1. Now we're told up here that sine of theta equals 4 over 5, so we can replace that here. So 4 over 5 squared plus cos of theta squared equals 1, and now we're going to rearrange to find cos of theta. So we square 4 over 5 and take it to the other side, so it becomes cos of theta squared equals 1 take 16 over 25. Now down here we know that 1 is the same as 25 over 25, so cos of theta squared equals 25 over 25 take 16 over 25. Now we have to simplify that, so cos of theta squared equals 9 over 25. Now we want cos of theta alone, and it's squared here. So what we have to do is we have to square root 9 over 25 to get cos of theta by itself, and the square root of 9 over 25 is equal to 3 over 5. Now we know that we have to keep this answer positive because we look back at our quadrants and see that where theta is between 0 and 90 degrees, and between 0 and 90 degrees all of them are positive, so we keep 3 over 5.
So another example of using identities is with the question of solve for x. So this question is sine of 60 degrees equals cos of x, where we are finding x in cos. We know that we are going to be using our second rule as sine of 90 degrees take away theta equals cos of theta. And we know this rule is what we need because we are finding x in cos. Making sure that we use our second rule and not our third rule as our question is written in degrees and not radian. So to work out our equation, we start with sine of 90 degrees take 30 degrees equals cos of 30 degrees. Now we know that sine already up here in our rule is 90 degrees take away theta. How do we get theta? We know that sine equals 60 degrees already, and 90 degrees take away 30 degrees equals 60 degrees. Making sure that we continue along our rule of keeping theta the same in both sides, so that makes our 30 degrees on either side. We subtract our 90 degrees and 30 degrees, giving us sine of 60 degrees equals cos of 30 degrees, leaving us with x equals 30 degrees.